I'm doing a recording of it so you can pause it and go back and re-listen to it at any time that you want. We have to take into mind that sine has an amplitude of 3, so the amplitude is changing. This part here is called the phase shift because the period is changing and we get a horizontal shift. So what we're going to do is we're going to take the key points for sine. So that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. I know these two are max and mins. The rest are zeros. So I'm putting z's with them so I remember that they're the zeros. So first thing I'm going to do is I'm going to take my first 0. So parent graph, the point would be 0, 0. I am going to take this, set it equal to the phase shift, solve for x. Divide both sides by 2, and x equals pi over 2. So that means this point 0, 0 is shifting to pi over 2, 0. Next point. So we're finished with the first one. I can put a little check mark there. The next one, pi over 2. Set that equal to x minus pi. Add pi to both sides. So what I'm going to do is instead of adding pi, I'm going to add 2 pi over 2 because I'm finding a common denominator for what's on the other side. So I'm planning ahead. So I end up with 3 pi over 2 equals 2x. Instead of dividing by 2, I am going to multiply by 1/2. It just makes dealing with the fractions easier. So then I have 3 pi over 4 equals x. So originally, because this is a maximum, my point was pi over 2, 1, because the amplitude of the parent graph is 1. It is going to switch to, or shift to, 3 pi over 4 with an amplitude of 3. All right, we are going to go through and do this with all of the points, so hang in there. That is why you're not getting very much for homework, because these problems take a little while. So my next one, and this is a 0. So we have 2x minus pi, add pi to both sides, divide both sides by 2. All right, so this seems weird. This is what it started with. So I know it started with pi 0, and it's going to pi 0. How does this make sense? Because we might think that this isn't making sense. And maybe we did make a mistake. But looking at this, what we can figure out is that the change from here to here is pi over 4. The change from here to here is pi over 4. So I know that about my key points is that they're all evenly spaced. So this, even though this is weird, it's still correct. All right, moving on to, we have 2 more key points to go. So 3 pi over 2, which is going to be one of my minimums, equals 2x minus pi. I'm going to add 2 pi over 2 again to both sides. And I'm doing this so I'll have common denominators. So we have 5 pi over 2 equals 2x. Then we're going to multiply both sides by 1/2. And we'll end up with 5 pi over 4 equals x, which, if we notice, is pi over 4 away from the previous one. So if the pattern is holding true, we don't necessarily need to keep adding because this is plus pi over 4. So I can actually get my last point based on the pattern, and going from here to here would be add pi over 4. So 5 pi over 4 plus pi over 4. Sorry, getting ahead of myself. Is 6 pi over 4, which reduces to 3 pi over 2. And it is a 0, so that is my point. If you want, you can verify it by going through and say 2 pi equals 2x minus pi. Add pi to both sides, go ahead and go through the process, and you're going to end up with the same thing. So we have all of our points. If, in order to, we found the amplitude, we need to find the period and the phase shift. So we figured out that it's shifting right pi over 4. So this is the phase shift. And the phase shift takes into account the horizontal shift and the period change, so you can't just read it from the graph. The new period. Well, we're starting at pi over 2 and going to 3 pi over 2, so 3 pi over 2 minus pi over 2 is 2 pi over 2, which equals pi. So my period is pi. I could have also figured that out because 2x, I take the 2 pi divided by 2, that 2 is going here, equals pi. So there's two ways to find the period in this. I like taking the last term minus the first term because that helps me double check to make sure I found the period correct both ways. So we've listed off all of those things, and now we just need to put those points on the graph. And then it also asks us to do 2 periods. So it is important that we label our points. And then the other thing that's going to be important for us to do is to make sure that we actually draw out 2 periods. So I find it easiest to label my points. So I'm going to label it down here so it doesn't get in the way. Pi over 4. Then the next one is, make this a little bigger. Pi over 2. 3 pi over 4. Pi. All right, so they're all shifting pi over 4. So if we're starting, I erase it because if we're starting at pi over 2, I want this one to be pi over 4. Pi over 2, 3 pi over 4. So now I'm just counting by fourths. Pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2. I'm going to keep counting the other way in the other direction. 0, negative pi over 4, negative pi over 2, negative 3 pi over 4, and I'll keep going if I needed to. So sine starts at 0. At pi, it was 0, and at 3 pi over 2, it was 0. So that means if you look, every other one is at 0. So I need to do that going in the other direction. So 0, 0, and one more, 0. So we'll just write in that other point that we need, which is negative pi. All right, I know I had an amplitude of 3, and since I started here, I'm going up 3, so 1, 2, 3, and then we go down 3, 1, 2, 3. When we draw our curves, we want them to be arc length and not pointy. My graphs typically look a little better. I'd make sure they always go down, up, down, up. And I drew this extra dot and I don't need it because I have 2 full cycles and we don't want to do extra that we don't need.